Thanks for tuning in and welcome back to the shop. If you're new here, this is our 2013 Mitsubishi Fuso FG and we're turning it into an overland camper. I've recently started working on the interior and today I'll be starting on the basics of the electrical system. If you watched last week's episode, you'll remember I assembled the lithium iron phosphate cells into a battery pack, and you may recall that the positive and negative colors on the cells were backwards. Now I said it didn't bother me, but I own a 3D printer, so I fixed it. These are just simple little 1.5mm thick rings that pop onto the terminals. So now instead of positive being black and negative being red, we've got things the right way around. Does it really make a difference to how the system operates? Absolutely not. But if anyone other than me is ever working on this system, I want it to be clear why things are the way they are. So with the location of the battery now sorted out, I'm going to need to move on to mounting things like the BMSs and the bus bars, the breakers and the fuses. And the shorter we can keep the wiring, the better. So I'm thinking right here is the perfect spot. Although this is the perfect spot, this is not the perfect surface. I don't want to be screwing or gluing things directly to the outside wall of the camper for an electrical component that I may need to change out later. Now, wouldn't it be great if I had a piece of material that was exactly the right size to fit that spot? Well, just like the battery pack, I think it's time to go to the kitchen again. Yep, another job perfectly suited for these oversized cutting boards. And with a couple more parts designed in SketchUp, using the extrusion slot for the center clip and the nut slugs to secure the upper and lower clips, these were easy to design and print on my Ender 3 3D printer in PETG filament. So now we can attach it to the T-slot extrusion. With a single 1/4-20 fastener in each corner, the upper and lower brackets are now secured. The center bracket slides into place, and though it doesn't provide vertical support to the board, it does stop it from flexing in and out. With the clips secured to the T-slot, I can slide the cutting board in from the top and position the center brackets halfway between the upper and lower brackets. With all the brackets and the board now in place, I can mark the 6 holes, remove the board and drill the holes, and then install 6 1-inch long screws to hold everything in place. Generally in a situation like this, I find the quickest and easiest way to mark these holes is just using the drill. To get the hole centered properly, the bit that I'm using is actually a clearance hole for a 1/4-20 bolt. The hole that I'm going to end up with there is a smaller hole, so I really just want to touch this so I get the center point. Now I can remove the board and drill it with the correct size to tap for 1/4-20. One nice thing about this plastic is it's soft enough for the screws to self-tap the holes, but strong enough that the threads will hold. This saves the step of tapping and allows the screws to just be driven directly into the drilled holes. If only I had 1-inch long hex drive screws so I didn't have to use these annoying Phillips head screws that I had sitting around. Well, at least with the fact that they're stainless steel, the heads don't strip instantly. And as easy as that, we have a nice, clean place to start installing the electronics. The nice thing about using an off-the-shelf thing like a cutting board is if you ever upgrade your electronics or maybe you screw up on your install, you haven't made holes in your camper and it's very easy to swap it out, go to Amazon and slide another one in. Now I really wish I didn't have to say this, but I do. This video contains information that may be useful in helping you learn about how to build your own electrical system. However, there may be key pieces of information unintentionally left out of this video, so make sure if you're attempting a project like this, you research, learn, and understand what you're doing so you do not injure yourself or damage your property. Working on an electrical system like this may seem like a simple thing to do. However, be aware that there are years and years and years of knowledge, and it's impossible to pass all that through in one video. With the mounting board in place, I can start considerations for placement of things like the BMS. But before I put these in, there's one more thing I need to do to the batteries. And that is installing the studs and the bus bars. And here's where I'm going to run into a problem. If you recall, these 4 cells are going to be combined in series to create one battery. That means my negative is here. I have to go from here to here with a bus bar. And that works fine, because that's exactly how these bus bars were designed to be used. My problem is the continuation of the series goes from here to here, and the bus bars are too long. If only there was a way to shrink bus bars. I need to make the bus bar shorter by 12 millimeters. We all know that the shortest path between 2 points is a straight line, and this bus bar is a straight line. So what if we make the bus bar not a straight line? By deforming the center of the bus bar, effectively that's what we are doing. I don't know if this is actually going to work, but I'm going to try 3D printing a miniature punch and die to effectively create a micro press brake that I can put in my vise to reform the bus bars. I'll print it in PLA at 95% infill, and I've upped the outer wall count to 6. This should make it stronger. These bus bars are 2 millimeters thick, so I hope it's strong enough. It takes a lot of force on the vise, but it is working as intended. I'll try the next one with the heat shrink removed so it can slide more easily. Sorry for the shaky video, my workbench and camera tripod move around quite a bit. Unfortunately, it does destroy the heat shrink, but underneath, the bus bar is perfectly fine. Not only perfectly fine, but now also perfectly sized to fit across the other direction. Unfortunately, the heat shrink that I have can't quite fit over the ripple in these bars, so I'll have to order some more, but I only need 3 of them, and it's not going to stop me from assembling the rest of the pack. Each of the terminals comes with a small stud to get installed. If you are working on a similar project, be extremely careful. Something as simple as dropping this little Allen key onto the batteries could end in total disaster.
The end of Sid the Sloth.
Once again, I cannot stress the importance of this enough. Make sure if you're about to place the bus bars on your battery pack, you understand 1000% that you're putting them in the right place. For my center battery, battery 1, I need a straight bus bar here, a straight bus bar here, and after I've heat shrunk it, I will place a bus bar here. This gives me full voltage here and ground here. For my outer 2 batteries, remember I'm using this cell with these 3. So I need to have a bus bar from cell 1 to 2, a straight bus bar from 2 to 3, and a straight bus bar from 3 to 4. This gives me full voltage from here to here, negative and positive. Lastly, I repeat the same on my second outer battery, bus bar across here. I go across here to here, and then I come back through here to there. Now I have negative here and positive here. And now with the correct colors in place and the bus bars in place, you can see my 3 negatives are in the center, and that's where my BMSs will go. And my positives are in a corner, in the center, and in the opposite corner. The BMS that I'll be using for each of these battery banks is a 150 amp daily K-type BMS. Each bank will have its own BMS, and they connect to the negative terminal and will be mounted above them. Before I can actually wire and mount the BMSs, there's 2 things that I need to do. One is mount the sensor leads that go to the positive of each cell in the bank. But unfortunately, with the way the BMSs are going to be mounted, these leads are nowhere near long enough. So that means I'll need to order some wire and extend all of the leads equally. And the other is install the active balancers that I'm going to have for each bank. But I don't have those yet. And those are 2 good reasons for you to hit subscribe if you haven't already, because you'll have to come back next time to see how that goes. Thanks for watching, and we'll see you then.
The end of Sid the Sloth.